In our video number 8 today, we are going to discuss the ordinal utility approach, which is otherwise called the indifference curve analysis or the Hicksian theory. Here, since it's the ordinal number, we are going to rank the utilities like first, second, third, and so on. Here we do not quantify as in the cardinal approach. That means we do not use numbers. Here, the consumer consumes two goods X and Y, which are substitutable. And then the consumer is indifferent to the goods. Indifferent or impartial. That is, his first choice does not affect the second choice. Now, the assumptions for the ordinal utility approach are as follows. The income does not change. It is given to us. We know the income of the consumer and the income is kept constant. What happens if the income changes? His preferences will also change. So income has to be kept constant. And the consumer consumes two goods that are substitutable. And the consumer is rational. Rational meaning that he will maximize his satisfaction. Then the fourth assumption is more of a good gives him more satisfaction. That means when he consumes more of a good, the more of the good will give him more satisfaction. Less of a good will give him lesser satisfaction. Now this more of a good giving more satisfaction is otherwise called monotonic preference. That means he prefers that bundle of goods which has more of at least one of the goods and no less of the other good. What does this mean? It means that at least one of the goods is consumed more, but the other good is not reduced. Let us look at this example. 5 of x, let us represent them with x and y. If this is x, then y, x and y. That means if he consumes 5 units of good x and 10 units of good y, then on the other hand, he consumes 3 units of good x and 10 units of good y. So you see over here, one of the goods is more. That means x has increased from 3 to 5. Whereas no less of the other good. The other good is y. He's consuming 10 and 10. It is no less than the other combination. Alright, so this is called as the monotonic preference. Now, an indifference set represents a set of combination of two goods that offer same level of satisfaction. It's only a set of combination. That means if he consumes 1 unit of x, he consumes 10 units of y, which gives him some level of satisfaction. Now, if he consumes 2 units of x and 7 units of y, this also gives him the same amount of satisfaction as the first combination. If he changes his combination to 3 units of x and 5 units of y, this would also give him the same level of satisfaction as the first or the second. Same is the condition with the fourth combination. 4 units of x and 4 units of y will give him the same amount of satisfaction as the first, second and the third. So this set of 1 unit of x and 10 units of y, 2 units of x and 7 units of y, 3 units of x and 5 units of y, 4 units of x and 4 units of y is called the indifference sets. So there are 4 indifferent sets. Right? Now, what is an indifference curve? The indifference curve is just the diagrammatic presentation of the indifference set. That means graphically, if we present these sets, then we call it the indifference. Then they form an indifference curve. Let's look at it. Now, if you try to plot these points, you have 1 of x and 10 of y. 1 of x is here because x is plotted on the x-axis and y on the y-axis. So this is what the scale has been taken. 1 unit is equal to 1 and here 1 centimeter is equal to 2 units. So 1 and 10 would be somewhere over here. 2 and 7. So this is 2 and this is 7 between 6 and 8. And 3 and 5. This is 3 and between 4 and 6 we have another point called 5, then 4 and 4, 4 units of x and 4 units of y somewhere over here. So now if you try to join these points carefully, you get a curve. So this is called the indifference curve, right? So how to remember this? Curve C. So indifference curve is a C-shaped curve, right? Now what do you observe over here is that the indifference curve is sloping downward, and there's one more observation, that if you want to increase the consumption of X, you have to reduce the consumption of Y, isn't it? So that is why it is a downward sloping. So what do we call this? We learned that these goods X and Y are perfectly substitutable. So you need to substitute one good for the other by sacrificing some units of good Y in order to gain certain units of good X. Now that is given by the law of diminishing marginal rate of substitution, or simply MRS. All right. Now here, the consumer, what does it law state? The law states that the consumer will be willing to sacrifice lesser units of good Y so as to gain each additional unit of good X. So he is sacrificing certain units of good Y in order to gain an additional unit of good X, which is given by the marginal rate of substitution, which is equal to delta Y by delta X. That means certain units of good Y that are sacrificed to gain 1 unit of good X. Now, since this is a downward sloping curve and we are sacrificing certain units of Y, the slope will always be a negative slope since it's a downward sloping curve. So the slope of an IC or indifference curve is given by the marginal rate of substitution, which is equal to minus delta Y by delta X. Okay, now when we look at this indifference curve, we observe certain things, and these are called as the properties of the indifference curve. What are these properties? This is how the indifference curve looks like, isn't it? It is a C-shaped curve. And see, it is not touching these x and y axis. So what do we understand from this is that it is a C-shaped curve and that two goods are consumed. A combination of two goods are consumed, isn't it? So the first observation of the property is that it is convex to the origin. Do you see this? It is convex to the origin. Why is it convex to the origin? Because it tends to decline. The slope of IC declines because the rate at which the consumer is substituting one commodity for the other tends to decline. And this is what we are calling the diminishing marginal rate of substitution. The second property is that it is downward sloping. We saw the marginal rate of substitution is a negative delta Y by delta X. Hence, it is a downward sloping curve. The other property is higher indifference curve shows higher level of satisfaction. We are going to deal with it in the just after this. Two indifference curves do not touch or intersect each other. And the fifth property is they do not touch either the x-axis or the y-axis. Let's see how. Under the ordinal approach, we learned when more units of a commodity are consumed, it gives more satisfaction. Therefore, a higher indifference curve shows higher levels of satisfaction. Now, if you see over here, I have drawn two indifference curves. Okay, so at this point on the, let us call this indifference curve 1 and this as indifference curve 2. On this indifference curve 1 or IC1, he is consuming 3 units of X and 10 units of Y. Whereas on IC2 at this particular point, the consumer consumes 5 units of X and 10 units of Y. So this is 3, 10 and this is 5, 10. So which would give more satisfaction? Obviously, the monotonic preference comes into picture, and here he is consuming 5 units, which is greater than 3. So IC2 will give him more satisfaction than IC1. So since IC1 is on the higher level, the consumer moves to a higher level of satisfaction. So IC2 will give him more satisfaction than IC1, or indifference curve 2 will give more satisfaction than indifference curve 1. Right? Now let's look at the other property. Two indifference curves do not intersect each other. Now here we have two indifference curves which are intersecting at a point A. Right? Now at point, now we call this as in indifference curve 1 and this as indifference curve 2. Let's now change, actually let's have some colors, so identify IC1 and IC2. Okay, so IC1 is represented in blue and IC2 is represented in red. Now A is a common point. This would mean that he is getting same satisfaction on IC1 and IC2. Is that possible? When A is present on both IC1 and IC2, it would mean that he gets same satisfaction. Now at A, the combination is 3 units of X and 8 units of Y. Okay. Now let's look at B. At B, he is consuming 4 units of X and 5 units of Y. At C, he is consuming 5 units of X and 5 units of Y, whereas on D, he is consuming 5 units of X and a lesser, let us call it 4 units of Y. Now what is happening? If A and C are lying on the same IC2, then 3, 8 and 5, 5 should be giving him the same level of satisfaction. But look at A and B. If 3 and 8 and 4 and 5 are giving him the same level of satisfaction, at B, he consumes 5 units of Y, and C also he consumes 5 units of Y. But at B, he is consuming 4 units of X, and at C, he is consuming 5 units of X. So obviously 5 is greater than 4, so C should give him more satisfaction than B, isn't it? So this is not possible. So A and C, if A is equal to C and A is also equal to B, then B should be equal to C. But here C is greater than B, isn't it? Now at D, he is consuming 5 units of X. At C also he is consuming 5 units of X. But look at Y. Y, he is consuming only 4 units at D, but at C he is consuming 5 units, which is greater. So C should be giving him more level of satisfaction than D. And C lies on IC2. So IC2 should be giving him more level of satisfaction than IC1. But here that is not possible. So two ICs cannot intersect each other. Now the other property is that the ICs do not touch x-axis or y-axis. What happens if they touch? Look at this first IC. Here it touches x-axis. Touching x-axis would mean that he consumes certain units of x, but y is 0, isn't it? So what do we understand over here? The ordinal approach says that the consumer must consume 2 goods which are substitutable. This would mean that he is consuming only good x and no of good y. Whereas here, when this IC touches the y-axis, it would mean that he is consuming certain units of y, but he is not consuming any of x. So x is 0 over here. Now again, according to ordinal approach, the consumer should consume 2 goods and both the goods should be substitutable. Now this shows that he is consuming only y and he is not consuming any units of good x. So ICs do not touch x-axis or y-axis. So those were the properties of indifference curves.